Good morning, good morning. It feels like it's only been a couple hours since I spoke to everybody last. Welcome back to day 2 of the 2021 Musky Symposium. I want to thank everybody for being up and at it this morning and joining us. We're going to start our day off with a great speaker, Dr. Sean Landsman. He is going to talk to us about his project, Project Noble Beast, and it's possibly the most influential muskie project in modern history for sure. And very excited to hear what he has to say. Sean is what you get when you have a passionate angler who gets bit by the musky bug and takes his awesome intellectual mind and puts it to our sport. So we're very fortunate to have Sean. I'm going to go ahead and read a little thing here, if you don't mind, written by Mr. John Anderson about Sean. Dr. Landsman fell in love with fish the moment he caught his first, a green sunfish from central Illinois. For his entire childhood, fishing consumed nearly all of his free time. He taught himself to double haul fly casts on the street and learned how to flip jigs by practicing hitting targets under white pines in his backyard. He caught his first muskie in 2001 and considers himself ruined from there out. After crossing paths with Dr. Cook in 2006, Dr. Landsman soon found himself pursuing his dream project, Project Noble Beast. This project has affirmed for the scientific community what anglers have been and researchers have been saying for years. Both within that muskie catch and release works. Dr. Landsman is not only a respected researcher, both within the angling and muskie science communities, but is also a talented teacher and a great science communicator, acting as the current president of the American Fisheries Society's Science Communications section. When he's not teaching students at Carleton University, he's either botching a big muskie in figure 8 or cutting gappy dovetails in his basement workshop. Ladies and gentlemen, I want you to welcome Sean Landsman and enjoy the presentation.
Thanks, Danny. Yeah, I've definitely been known to botch a few fish in the figure 8. That's for sure. Last year was certainly no. I can specifically remember some on a trip to Lake of the Woods that I botched that I would not have liked to have botched.
I don't believe people who live in glass houses should throw stones. So that's why I was very clear that it was Mr. Anderson.
Yeah, it's all good. We've talked about that before for sure. Yeah.
Perfect.
Yeah. All right. Great. Thanks, Danny. So we can throw my first opening slide up here. Yeah, I'm gonna talk to you all. Oops, excuse me. I'm gonna talk to you all about Project Noble Beast. This is now going on about 10 years. This project is about 10 years old at this point. It was the focus of my master's work. It was, I don't know, it was quite the experience. It was kind of my first foray into the world of academia, and through the lens of musky science, and getting to work with a community that I had been steeped in for years as an angler. And it was really kind of a dream come true. And I'll talk a little bit more about the the origin story, I guess, of Project Noble Beast. I threw up this picture. Actually, I texted my father last night and said, "Hey, if you've got that picture of my first muskie back from Evergreen Lake on September 9th, 2001, just take a quick picture of it. I'll throw it up on the presentation tomorrow." But yeah, that's my first muskie there. Was a 36-incher caught on a Northland Bionic bucktail spinnerbait. I think it was like mostly orange with a bit of black. And I was like totally hooked from that point forward on muskies. Prior to that, I had been a dyed-in-the-wool bass fisherman, and but once I encountered my first muskie, I pretty much put down all the Texas rig worms and tiny torpedoes and traded those in for bulldogs and top raters. So it has become a really kind of a lifelong deep passion or obsession of mine. So in 2006 or 2007, I can't quite remember what year it was, I ended up meeting Dr. Cook at the Queen's University Biological Station just north of Kingston, Ontario. And we chatted a bit about what I wanted to do post undergrad, and and he said, "Hey, if you want to, if you want to come up here and do a master's, like, what would you want to do?" And that's really rare to be asked if you would like to pursue a project of kind of your own design. Typically, you've got a professor who has funding in place, and so you kind of work on a project that they have. But he invited me to kind of create my own, so I created this dream project of mine to pursue, the science of catch and release angling on muskies and to fill a bit of a knowledge gap. And for some of you, like, knowledge gap, catch and release like we know that they survive when we release them. Well, yes, definitely. Except that in the scientific literature, up until my project, the only science-based estimate of catch and release mortality was from this study here by Gail Beggs and colleagues in 1980, that said there's a 30% mortality rate of muskies that are caught and released. And so management agencies, when they need to look at evidence in order to make particular decisions about how to manage muskies, like enacting high size limits, right, high length limits, the assumption there is that the fish that you release are all going to survive. And so if you've got a bunch of fish that aren't surviving because handling practices aren't good, then there's not much need to raise the size limits that high, because fish are just going to die anyway. I mean, there's that's sort of an oversimplification of how the regulatory process proceeds and how you actually come to the decision to raise the size limit, but that would certainly be one of the factors. And so, again, I knew, and the angling community knew, that there's no way 30% of muskies end up dying. And but we did need to explore it. So the prediction was that we would see maybe some mortality, but that it probably wouldn't be 30%, considering that this study was done in 1980. And that was quite a long time ago, and lots of advancements had been made since then. And so I set out to create this project. And as I was creating it, I wanted a fun name. I wanted a catchy name. It's kind of something that Dr. Cook does in his lab. Comes up with fun names for projects. And since I knew I'd be doing a lot of outreach with the angling community, I wanted to have something that people could glom onto and associate with this project. So I thought about a name, and I came across this paper detailing the life of Dr. Ed Crossman. So it was written by John Castleman, which was one of his longtime colleagues and close friends, also a really well-known muskie researcher. And it was written shortly after Dr. Crossman's passing. And I was reading through it, and there was one paragraph that really just popped out to me. And it was when Dr. Castleman said that Dr. Crossman referred to muskies as noble beasts. And I thought to myself, that's it. That's the name of this project, Project Noble Beast. And then, of course, in that same paragraph, it went on to say that Dr. Crossman particularly enjoyed interacting with muskie anglers, which, of course, I do wholeheartedly. So I felt like a strong connection to Dr. Crossman in that moment, and really felt like naming this project as a bit of an homage to the late, great Dr. Ed Crossman would be very appropriate. So there's the origin of the name, if anyone was ever curious about that. So what are the goals of Project Noble Beast? I had more or less three chapters to my master's thesis. The primary chapter was looking at the lethal and sublethal impacts of catch and release angling. And again, that was meant to be kind of an update to that prior study that was done in 1980 by Gail Beggs, to now test current handling procedures using modern day muskie equipment, strong rods, super braided line, knotless, large landing nets, and refined handling practices that anglers in the angling community had developed and then educated others on over a long period of time. So that was kind of like the main component of Project Noble Beast. A second chapter to it was we wanted to look at summer activity patterns of muskies. So we wanted to kind of have a very applied aspect to it through the catch and release work, and then we wanted to have kind of more of like a fundamental, just kind of curious what are the activity patterns of muskies, and can we use these at the time, pretty new technology of using these acoustic accelerometer transmitters and put them in muskies to see what their activity patterns were. And then, there was also this other question related to live bait. In 2007, there was a study by Wisconsin DNR scientist Terry Martineau, and he published a paper looking at injuries associated with J-hooks, J-hooked live bait. And found pretty high mortality within a year. I think there were like 80% of the fish that had been gut hooked ended up dying within a year. About a quarter of them maybe within, I think it was a month or so. So for some pretty substantial mortality associated with that, which is probably not surprising to anybody if you let a muskie swallow a big sucker with a giant J hook in it, and then you go to set the hook, and that hook rips through the stomach or and nicks other internal organs. That's not going to be very good for them. But we were also interested in saying, okay, well, in lieu of a J hook, and maybe in lieu of more complicated setups like quick strike rigs where you got to like thread the rubber band through the nose or use a little Aberdeen hook through the mouth, and then you've got the wire harness to 2 treble hooks. It gets a little complicated. Could we use circle hooks? And circle hooks are used, my gosh, in all sorts of fisheries. And work really well in a lot of fisheries. So why couldn't we apply them in muskies? And so we set out to try and explore that. I'll talk a little bit more about what happened with that. If any of you watched Dr. Cook's presentation yesterday, he basically said that the punchline there was very hard to catch muskies on live bait, which very much surprised me. And so it didn't go kind of as planned, but we can talk about that more in a little bit. Okay, so let's dive right into this. So for that first chapter, where we were looking at sublethal and lethal impacts of catch and release angling, we had a few questions, and so here's some of them here. What is the post-release mortality of angled muskies? Again, Gail Beggs and her colleague and his colleagues had 30% more estimated mortality rate. It's quite high, but given current handling procedures, what is it sort of today, quote unquote? How much stress do muskies undergo during the angling process? A lethal impact is one endpoint of the angling process, but if a fish doesn't die, well, what else happened to that fish? And so, are there ways that we can maybe minimize stress? And again, our current handling procedures appropriate? And so if they aren't, can we do something different? And so we ended up actually testing 2 different handling procedures. So I'm going to go back for a second. So this is a 50-incher that we caught for the project and tagged, and it was subjected to one of our quote normal handling treatments. And I'm very stressed out there, as you can see. I'm in a weird position. The fish was very heavy, but I was also very stressed out because my angler volunteer from Muskies Canada ended up hooking himself on the fish. I was caught on a bucktail, and he reached into the net to unhook it, and the fish just thrashed over and buried the treble in his finger, and the hook point was parallel with his bone. There was not much we could do, but in my panic, I grabbed the bolt cutters and then cut the hook, only to realize that I cut way too far down on the shank. We were going to try and pop it out, but we basically couldn't do that at that point. So that's my face in the background now, realizing we've got all this tracking to do, and my awesome angler volunteer has this giant 5/0 hook stuck in his finger there. He actually got it out about 4 hours later after going to the emergency room, but he was a champ because we did all this tracking after he didn't want to go in and lose all that data. So that's my face back there, being very stressed during the angling process. Okay, so what did we do for this? We radio tagged 30 muskies to determine survival. So this is for the mortality / survival component of this chapter. We actually tested 2 handling practices. So we had a normal handling practice where we basically, what differentiated the 2 was there was a period, of air exposure, and in the normal treatment, and then in the gentle treatment, no air exposure. The period of air exposure in the normal treatment was 90 seconds. And if I'm a betting man, some of you out there are going, what? 90 seconds? That's like way too long. If I hold my breath for 90 seconds, that's insane. What we did before we started the project was we actually surveyed anglers from Ottawa and surrounding areas, including down by the St. Lawrence. And one of the questions we asked was, how long do you think you hold muskies out of the water? And we had, a range probably from like 30 seconds to, a couple minutes or a few minutes. And so we kind of decided to take the middle road there. And choose 90 seconds. So, when you factor in, like, if some really highly experienced anglers are going to keep that very minimal. You've got kids on board, you're going to want to be looking at the fish, maybe taking some video, a bunch of pictures, bump board on, out of water on the boat. So that all adds up in terms of air exposure time. We also blood sampled a total of 77 muskies caught from a variety of different systems, mostly the Ottawa River, but also some from the Rideau River and some other areas within the Rideau system. We caught them up to 79 Fahrenheit, and I'll talk a little bit more about that later, why that's kind of important. Okay, so what were our major findings? Well, major findings and conclusions were that none died. Now, before you're all, woo, wow, we have 0% mortality in our catch and release fisheries. That's impossible. I've had at least probably 2 fish die that I know of during my angling career. I'm sure some of you have experienced that as well, as unfortunate as that is. So you can never have true 100% survival in a catch and release sport fishery. But I think what we can confidently say is that under current handling procedures, mortalities are likely negligible. So this was none died for either of the 2 treatments, whether we held them out of water for 90 seconds or didn't hold them out of water. We showed that there was relatively little stress induced during the angling process, particularly between the 2 treatments. When we compare them to what we call a control, which was electrofished muskies, you can't get like a true control. You can't hand a fish a blood, a vial and say, jab this needle in yourself and take your blood and then hand it to me. You can't do that. So we had to electrofish muskies for our controls, which are kind of as close to getting a true control as we can get. But so sometimes there were some differences between the controls and the angling groups, but certainly between the angling treatments, we saw relatively little stress, except during high water temperatures, like approaching that 26 Celsius, high 70s mark, and when fish were held out of the water. So I'll talk about that in a second, what that means or what my recommendations would be for that. But all told, I think our major conclusion there is that current handling practices are really quite appropriate. So what are my recommendations to anglers based on this work? Really to kind of embrace the principles of this keep fish wet movement, which Dr. Cook talked about yesterday. It's really to reduce air exposure, reduce handling time, reduce contact with dry surfaces. But the best thing you can do for the fish is keep air exposure to an absolute minimum, especially during warm water temperatures. You really want to keep that to as little as possible. Also, don't overhandle your catches. I personally, when I catch a fish, maybe pose for a quick picture and put it back in the water. If it's upright, I just let it go. I just, turn around and start organizing the boat and, just check on the fish. If it's upright and swimming away, great. You don't need to sit there and slosh it back and forth to get water moving over its gills. Just stop handling it at that point. Cut hooks as quick, as often as you can, instead of, dilly-dallying with a set of pliers. And then the other thing too is just like, think critically about whether you really need to measure every single fish that you catch, or if you can get a length estimate and that's kind of good enough, right? Do we really need to measure another 34 incher? So that's up to each individual angler, but I would certainly encourage people to, maybe just consider going, yeah, that's a nice mid 30 and letting it go and not bother getting handling it any further by measuring it. But there were some other notable secondary findings. So these are things that we gleaned that weren't part of the, we weren't really super rigorous with it, but these were things that we gleaned from some of the radio tracking that we did So we were just radio tracking periodically to ensure that these fish had survived, and then just because we were kind of curious and we had the time. So I should mention there too that 7 of the radio tagged fish were actually recaptured, which is kind of cool. And there's a pic at the bottom there, or side by side, 48 incher that was caught for the project in 09, and then was later caught by another angler in 2014 at 51 inches. And that was caught from the same large complex structure. And that was kind of one of the things that our radio tracking showed us, was that these areas that had very large complex structures tended to hold fish, especially during the summer, but even into the fall, around those areas. Whereas if we caught fish from small weed beds, like the biggest fish of the study was a 52 incher, caught from just some little kind of, I don't know, just some little scattered weeds along the shoreline that we just happened to come across that I noticed had tobacco cabbage. And then we came back the next morning and caught this 52 incher on a pacemaker. But we never tracked that fish back to that spot ever again. And it boogied the next day. It moved almost a kilometer downstream and then never returned back to that location, at least that we were aware of. Some other things there, 50 incher in 3 feet of water. There was another fish we tracked that day in late November 23rd. So big fish will still use shallow water well into late fall. Weeds don't have to be green to hold fish. I think that's a misconception that a lot of anglers have, that if the weeds aren't green, then there's no point in bothering them. Weeds still provide cover. There's still material for little bugs to eat, which means there's going to be reason for little fish to be around eating those bugs, which means there's going to be reason for bigger fish to be around to eat those little fish, right? So weeds are still good well into the fall. Not all spots have the same fish holding power. I just kind of mentioned that about larger complex structure versus smaller spots. And muskies tend to move back and forth from deep to shallow. I mean, one of the things I sort of joke about from the study was I learned that muskies are kind of random. They seem to move back and forth quite a bit. Where you would typically be casting, fish might be like right behind your boat, 20 feet behind your boat, kind of right between that break line that other anglers might troll and between where a boat might be casting. So it's kind of pretty random, I think. But it does show that they will move back and forth and use shallow and deep habitats. Chapter 2, activity patterns of muskies. So this is where we applied some really kind of interesting technology to help us understand more about the activity patterns of free swimming muskies, as opposed to ones that might be held in a laboratory setting or something. So we also were curious to know, are there cycles of activity? These daily cycles, they call them in biology, we call them diel cycles. And so this is like a 24-hour cyclic pattern of behavior. So do we notice this in muskies in terms of their activity patterns? So we were using these little transmitters. You can see bottom left there, not, probably about the size of like a AAA battery. These tags had pressure and acceleration sensors within them. So there was a triaxial acceleration sensor. So it measured acceleration in 3 different axes and then averaged them together to give us a value. We put these inside fish as well as attach some of them externally. They had about a 3-month battery life, so we were only kind of able to keep it confined to the summer period. And these aren't loggers where like the data gets stored on the tag. If a fish is within kind of earshot of the receiver, which is like the underwater listening station I'm holding bottom right there, then it will transmit the data to that receiver, and then the receiver logs that data. But if the fish is somewhere far away from one of those receivers moving around, we don't know what its pattern of activity is at that point. So it does have to be within earshot of that receiver. So major findings and conclusions. One of the things we found was that, at least in this system, which is fairly shallow and quite vegetated, so maybe different than something like the St. Lawrence, for example, or Georgian Bay, much bigger water. This is a kind of a medium-sized river system. But we found that they remained nearly motionless. About 70% of the time, they were basically just sitting there not doing anything in these areas, around the receivers. These areas around the receivers would have been, kind of shallower water in and among vegetation, maybe listening out into some of the, close to the break lines or weed edges. But this is pretty much in keeping with what we know about muskies, which is that they're a sit and wait predator. So I personally wasn't really surprised to see that they aren't moving all that much. We did find that they actually display cyclic patterns of activity. Again, at least in this system, could be different in other systems. One of the interesting things was that they peak. Their activity seemed to peak at dusk. So for everyone that likes to fish prime time and is not a fan of getting up real early, there is hope for us. And we're doing something right if we're fishing into the dusk hours and twilight. So what we saw was that activity was lowest at dawn, and then as the day progressed, it got higher and then peaked at dusk, and then started to taper off at night again to a low at dawn, and then it sort of repeated itself in that pattern. Smaller fish tended to actually be more active than larger fish, and I'm not super surprised to hear this. Smaller fish may be forced out of areas by larger muskies, or they're interested in eating more because their growth rates are higher and their metabolisms might be higher as smaller individuals. So I wasn't super surprised to hear this. Activity peaked at around kind of the mid-range of the water temperatures that we were collecting data in. So the range was 20 to 28 Celsius or 68 to 81, and it peaked around 75 Fahrenheit or 24 Celsius. So kind of right in the middle there, which is more or less in keeping with what we know about preferred water temperatures of muskies. So which is in that kind of mid to high 70 range. Okay, and we'll talk about chapter 3 now, circle hooks and live bait. Yeah, again, this was challenging. Not very naively, for any of you that have spent any time fishing live bait, I'm sure you know that it's not as easy as it sounds. Well, naive Sean just assumed that throw a sucker on a hook and it's like shooting fish in a barrel. That couldn't be further from the truth. I was shocked. I seem to recall calling Steve in a bit of a panic, kind of midway through the fall, going, "Steve, this is not working. I don't know what to do. We're just not getting the data that we need to be getting for this, and I'm not sure that this is going to work out." So we did the best we could, and I'll explain in a minute kind of what we saw. But what our big question here was: are circle hooks a viable alternative to J hooks or quick strike rigs? So we got a permit to run more lines than is typically allowed in Ontario. So we ran with like usually three anglers on the boat. We either ran 3 lines or sometimes actually doubled up and ran 6 lines. So doubling up on the 3 different types of live bait hooking procedures, either quick strike, J hook, or circle. For time to hook sets, they were, for quick strike rigs, it was right around 30 seconds. We had a timer. Everyone had a timer around their necks, and so if a fish grabbed the bait, we would start the timer and then hit it set the hook after 30 seconds. With the J hook, there was a local angler that we consulted to understand a bit more about what he was doing out on the water. And Terry Margano had already established that if you let a fish swallow the bait for 10 or 20 minutes, like that's no bueno. That's not very good for the fish. So we were kind of curious to know, okay, well, if people do use J hooks, can we recommend that they say, set the hook after 60 seconds or maybe up to like a maximum of 3 minutes? So we used these J hooks with shortened time to hook sets of 1 to 3 minutes after letting the fish grab it. And then for the circle hooks, the hook set there was kind of at the angler's discretion, because we weren't really sure how long or what we needed to do there to ensure that the fish would survive. So we wanted to have enough data to maybe make a recommendation there. And for any of you that have used circle hooks before, you know that you can't set set the hook like you would a normal J hook. It's more of just like reeling down on the fish and tightening up that line to allow the hook to kind of come up through the mouth. And then as the line is coming off at an angle like this way, the hook then rotates around as it's getting pulled backwards by the line and then lodges in the corner of the mouth. That's the idea of the circle hook set there. So after like 5 or 6 minutes, I think our anglers would reel down, and that's Bill Fuller there, local Muskies Canada member, fighting a fish that we had hooked on a circle hook. I think it got off. I think it was that sucker there actually. So we didn't actually end up landing that fish. Major findings and conclusions here. Again, definitely not easy to catch fish on live bait. Certainly wasn't for lack of trying. But because we had such difficulties catching these fish, it really did result in a low sample size. We had 5 total fish that were landed, 2 on J hooks, 2 on circle hooks, and 1 on a quick strike rig. I think one of the major findings that sort of is intriguing is that the circle hooks did actually seem to work pretty well. We had 1 fish that curiously was caught right in the roof of the mouth. I don't even know quite how it stayed hooked, just because the hook tends to bend inward. You can see the point of that hook there kind of bends inward. So anyway, it got hooked there and stayed hooked. But the other fish you can see there is exactly what you want to see with a circle hook. It's exactly what you want to see, right in the corner of the mouth, grabbing onto a ton of, a bunch of flesh there. So, you have a good chance of getting that fish in, but at the same time, is in an area of, relatively low damage and low risk to the fish in terms of significant injury there. So it's exactly what you want to see. But unfortunately, we just didn't have enough fish to make real thorough recommendations here. We did have 1 fish that died with the J hooked rig, which was kind of surprising given the fact that we didn't let the fish take it for that long a period of time. So you can see there, that's actually the necropsy of the fish. That bottom right photo there, that where that yellow circle is, that's actually what we believe was the tear caused by the hook in the fish's esophagus there, and it looked like there was some other internal organs that might have been nicked as well. So we weren't real happy with these. This is a natural reproducing population of muskies, and we saw that 1 fish die. I also had like real misgivings about the future of this project and whether I really wanted to be kind of doing something as risky as this was to the fish. So the fact that we were having so many struggles trying to get these fish, and that we saw 1 fish die, I was, I think I told Steve, I think we just need to kind of give up on this and maybe revisit this at some point in the future. So we ended up kind of abandoning it at that point. So we didn't actually end up publishing this. It's in my thesis. If anyone wants to read 144 pages of my thesis, feel free to email me. It's in there as an appendix. But in any case, it was kind of intriguing to see that maybe there is some hope for using these circle hooks. I want to say that Project Noble Beast was really a highly collaborative project here. So you can see these are just some of the pictures that I was going through last night. Of people that were helping me, and from Muskies Canada volunteers to a bunch of my fellow lab mates. Like that picture there in the middle there was 2 of my lab mates. We electrofished a 49-incher out of the Rideau River, and but I had Charles Weiss bottom left there, the musky artist, Hedrick Wachelka there in the middle photo with another Ottawa area angler. Same thing in that middle photo there where I'm bending over that trough. We had Hedrick Wachelka and then another Ottawa area angler taking notes, and the late Ed Sanford top right there. If anyone ever met Ed, what a colorful character he was, diligently taking notes and recording data when we caught a fish. And then Jim Hutchings, famed St. Lawrence River fisherman, came up for a late fall day of tracking. So it was a super highly collaborative project. I'm deeply grateful to all my volunteers. And again, on a personal note, I met some really, really amazing people. It's one of the absolute pleasures of working within this community is just the amount of support and generosity that anglers show. So, for example, Ed, top right there, one day just calls me up and says, "You want some moose and bear and venison burgers with 65% deer and 35% pork?" I said, "Absolutely." So it was the generosity of folks like Ed and everyone else that donated all their time. That was really wonderful. I had a lot of anglers from that helped with the project actually came to my wedding on Prince Edward Island. That was super special. I just finished building a dresser with one of the club members for my new baby. We're expecting May 8th. So these are lifelong friendships, and if I had not ever done this project, I wouldn't have met any of these people, and it's just been a real pleasure working within this community. I realized that I don't think I have a slide about kind of future pathways of Project Noble Beast, and so I'll just take a moment to talk a little bit about that. I'll throw up on this slide here my contact information here, but I'll talk a little bit more about what I think might be the kind of future path for an extension of Project Noble Beast. I get asked one question probably more than any other, at least in the last few years. And that is what's the kind of maximum depth that we can safely catch muskies at? And the fact is that I don't have a good answer for that. Muskies can experience barotrauma, maybe not to the same degree as a smallmouth or a walleye might, just because of how their swim bladder is structured, makes them a little less prone to the effects of barotrauma, but nevertheless, they can still experience it. And it doesn't necessarily have to mean that they will experience it only when caught from like 20 to 25 plus feet of water. I hear reports of people, very credible reports from people that have caught fish from 10 feet or less, and the fish displayed clear signs of barotrauma. So the question becomes, what's the effect of pulling muskies, at least from deep water, on their mortality and survival? So I think that's kind of a next step. Another natural extension of our work, which is actually already happening, is warm water, mortalities and stress associated with angling muskies from warm water. So if any of you caught that earlier, we caught muskies in the project up to about 77 Fahrenheit. And there's concern. There's a lot of areas, especially in the States, where the water temperature gets well above 80 and stays above 80 Fahrenheit for a long period of time. I was born and raised in the state of Illinois, and we had temperatures pretty much from like June through say like late August, early September, where the water temperatures were at 80 or above. And so our study didn't really address that. So there's now currently a study going on with Dr. Derek Crane and some of his colleagues and students. It's actually happening across multiple states, which is really kind of cool. Wisconsin's even gotten involved in doing some work in research ponds related to the study. But they're trying to get at the question of, what's the mortality associated with angling muskies from warm water, and they're doing a lot of that work down in the south. So areas like Virginia and some of the southern musky waters. So again, that's a natural extension of this work, and it's be interesting to see what their results show in the coming years. I know they're actively working on that right now. So with that, I want to thank everyone for partaking in the Musky Symposium and opening up your wallets. Certainly from the standpoint of a researcher, it's really awesome to see all of the support that people have been willing to show for musky research, and certainly share the same gratitude that Dr. Cook expressed yesterday. It's really great to see. So thank you.
It's us that should thank you, Sean. It's a terrific presentation. Your hair is making me a little bit self-conscious about mine. So I don't know if we'll have you back again. No, I'm kidding. You're amazing. I really loved how you're showing us, ways to track, ways to see the fish, and how we as a community are going to be part of the whole process. That's really part of what this is about, really, because we're raising money, but we can't rely on the government or other places to source and fund this type of research. So it really becomes incumbent on us as a special interest group, if you will, who have a love and passion for the angling, to to do our part. So I'm hoping the symposium is doing its part. I know Muskies Canada and their Odyssey did their part, and hopefully collectively together we can keep this going. Sean, you are always making yourself available, so thank you on behalf of the Musky community. And
no problem.
He's not kidding. If you're watching and you have a question, you send him a question, he's going to answer it. And if you want to read his paper, read his paper. He really truly does put himself out there for the world. And so thank you very much for joining us this morning. Enjoy the rest of your coffee. And
thanks for the opportunity to talk. And as Danny said, anyone has any questions, I really do. It's one of the things, one of my soapbox things. I really do feel like I owe it to all those that have helped with my research, and just if anyone's curious, please reach out and ask questions, and I'll try and always take the time to answer your questions. So thanks for the opportunity to be here.